So, about 2 months ago, the Earth was visited by a small celestial body. It was a comet called 12P Pons Brooks. And so I had the opportunity to drive to a field near my house and set up a telescope and then try to take a picture of this incredible type of object. Pretty cool. But see, the thing is, as I gazed out to the horizon and squinted my eyes against the tree line, I could just barely make out what seemed to be a sort of fuzzy, elongated cloud. And it kind of disappeared when I diverted my vision away from it. It was about the width of maybe my pinky finger held an arm's length away. That's it? It's a comet, a fiery ball of dust and ice flinging itself apart under the fury of the sun. And it's just a fuzzy smudge on the horizon. So it seems like our vision is kind of limited. The word nebula comes from Latin for fog or mist, meaning it's indistinct and hard to see. And before astronomers even had telescopes, well, anything, whether or not it was a galaxy or a star cluster, was just called a nebula. The reason for this, of course, well, space is dark. I'm sure we're all used to these beautiful photos from the Hubble Space Telescope, or in this case, the James Webb Space Telescope, and they reveal these huge undulating slopes of nebulous gas and uncountable star clusters and a plethora of galaxies dotting the background. And it's kind of easy to imagine that were you to find yourself here in space, you'd be blinded by the power of the millions of stars in front of you. But as you might know, the reality is really quite the opposite. You would struggle to pick out defined details. And so, what can we do about this? Well, what is happening, let's do a thought experiment, okay? I'm going to throw you into space. Sorry. But I am going to give you a spacesuit, all right? What will you see? So let's assume that your eyes start off naturally adjusted to the daylight on Earth, or these spotlights. These spotlights are way brighter than the stars in the night sky, so at first you're going to see nothing. It's going to be black. But if you give it a second, your eyes will start to adjust, and then you'll start to see some stars appear, and the amount of stars will grow. The contrast will become more defined, and you'll start to pick out the different blues, oranges, whites, and yellows of the different stars. And after a few minutes, your eyes will have adjusted well enough that you'll start to see a big gray band surrounding you in a full 360 degrees. The Milky Way. That's what it would be reduced to. The grandeur of our home Milky Way galaxy, just a fuzzy cloud in the night sky. But what I just described to you was the process of your pupil, the little black bit in the center of your eye, expanding and letting in more light. As it expanded, everything you saw got brighter. Do you think that maybe there's a way we can make the pupil bigger and let in more light? No. Anyone who's got maybe eye surgery would know that your pupil can dilate and become very big, but you would also know you can't see a darn thing. What we can do, though, is we can get a telescope, and that will allow us to capture more light. Let me explain. Light travels through space in the form of a particle called a photon. And photons will race across some large distance from a star to us at 299,792,458 meters per second. That's fast. So imagine that a given photon has traveled this massive distance all this way, and it is very, very lucky and just so happens to intercept planet Earth. And if a given photon is very, very, very lucky, it might come all that way just to end its journey right through your pupil and be absorbed by your retina. That's how you see a star. Now, I want you to imagine this incoming barrage of light coming from stars as rain. Falling rain. And I want you to imagine that your pupil is like a glass of some sort. So if you set that glass outside, it's going to start to collect that rain. That is, if you were to expose your pupil to starlight, you would start to see the star. And of course, if we had a bigger glass, say, it would collect more rain. Okay, let's imagine that your pupil, while it's small, when you saw black in that thought experiment, is like a shot glass. And let's imagine that when it's bigger, it's kind of more like a drinking glass. So it expanded, and it's letting in more light. Okay? So that's great. We can start to see more, and our biology has allowed us to do that. But it does stop after a while. The pupil can only expand so far. The iris can only stretch it open so much. So in that respect, we are limited, but this is where the power of a telescope comes into play. A telescope's aperture, which is the width of, say, the glass or your iris, is much bigger than your eye, as you might imagine. Say the surface area of your pupil is 0.4 square centimeters. Compare that to a 6-inch wide telescope mirror, that's 180 square centimeters. So that many more photons are going to be able to come from space and land on the telescope mirror, which means you're going to have that much more light. The image is going to be that much brighter, which means that much more detail in whatever nebula, galaxy, or star cluster you happen to be looking at. Okay, that's great. So that's how telescopes allow us to see more and get more light. So you get a telescope, nice big mirror, and you throw it on outside. Say you've succumbed to a common affliction of astronomers called aperture fever. It recently caused me to buy a big 10-inch wide telescope that sits around this tall. Best purchase of my life. So what it will allow you to do if you slap on a camera is take a picture of the sky, of course. So you set it outside, take a picture, and it looks like... what happened? Well, we forgot to account for one thing. This is something that every astronomer is very, very painfully aware of. Well, we're stuck on planet Earth. Earth rotates, completing a revolution once every 24 hours. And so what happens is that we, stuck, glued to the surface, see the whole sky appear to rotate around the north celestial pole, where there just so happens to be a completely bright star called Polaris, also known as Lodestar, the North Star, or to some Alpha Ursae Minoris. Now, of course, the sky is not actually rotating. It's us on the surface. So what can you do about this, though? Well, you'll see the whole sky rotate, just like that. So you need a mount of some sort for your telescope that will allow it to spin the same way. So you can get a thing called an equatorial mount. What an equatorial mount does is it basically gives the telescope an axis of rotation that is parallel to that one, where there is that bright star right in the center. And so it looks like this in action. You can see, as the sky spins, the telescope is going to follow it. So this is my telescope, and you can see it. The axis of the equatorial mount is pointed right at Polaris, and it's following the sky. I was shooting some star cluster or something. Okay, that's great. So now we have a telescope that allows us to see lots of light and can follow the sky. This completes a sort of crash course on how you can get through the basics of telescope optics and how you can get a telescope to follow the sky. And so I want to encourage all of you to get more into astronomy, learn more about it, and research and buy a telescope. Whether or not you want to take pretty pictures or just look at pretty stuff, it's really up to you. It's hard for me to describe what it looks like to look through a telescope because it is, for me, a very powerful experience. Many of us have looked at the moon or some of the planets like Jupiter or Saturn. Raise your hand if you've done any of those. See? But how many of you have seen a deep sky object? What a deep sky object is it's a massive, massive, truly unfathomably large object, a nebula, a galaxy, a star cluster. I could say how many light years across a galaxy might be, but how large it is, it means nothing. You could convert that into kilometers, but gosh, it'd be in the thousands, trillions, quadrillions. I will always hold close to me a particular experience in my journey with astronomy. I was first starting out with trying to take pictures of deep sky objects about a year ago, and I decided to shoot a fairly well-known galaxy called Messier 101, also known as the Pinwheel Galaxy. And so I set out. My picture came out, as all beginners do, terrible. It was grainy and fuzzy and out of focus, and I was absolutely thrilled with it, and I posted it on Instagram right away. I went scrolling through Instagram, as one does, and after a while, I started to notice that the astronomical community was sort of flaring up about something. A Japanese astronomer had noticed a suddenly brightening star in another galaxy. Not a brightening star, though. It was the death of one, a supernova, a star exploding outwards in another galaxy. Now, we see these all the time. So I wondered, and I was like, okay, what galaxy is it in? It was in M101, the galaxy that I just shot. So I went and I looked at my pictures, and I scanned the whole image, and I compared it to NASA's photos that they released, and surely enough, there it was, right there in front of the galaxy, A star that looked just about like any other, but it was not a star. I had no way of knowing, but it was actually the death of one. I'm subjected to the will of the cosmos just as all of you are. And every once in a while, if you're patient, it throws something at you that really takes you off guard and reminds you of how incredible it is that we get to be a part of this universe and to observe it. And so, in this age of space exploration, you might feel a little demotivated by the fact that most of us won't go to space. I'd be willing to bet none of us in here will. But the thing is, that actually gives us an interesting opportunity. We could be the last of humanity who had to yearn to embark for the stars instead of doing it. Just as the first ancient Greek and ancient Chinese oceanic explorers longed from the shores to explore the world's waters, we could be remembered by the rest of humanity as the ones who yearned from the surface of our planetary cradle to explore the heavens. We were born too late to discover the stars and too early to explore them, but we were born at just the right time, which is any time, to admire them. And so I ask you to join me in this age of the spacefaring humanity's adolescence. We will be the ones who longed to explore for the stars. And I want all of you to do that. Research and buy a telescope, and every now and then just escape from the city, get away from the light pollution, and join me in admiring, being humbled and awed by the beauty of our cosmos. Thank you.